Hi, good morning. So let's start. So I have a couple of new people in the class, so I will start from the very basic stuff again. For some of you, it might be a little repetitive, but as I have a couple of new students in the class, I'll still go for from the basic, and it might be helpful for some of the old student as well. So as we all know that we are going to do the database class today, the database testing. So guys, can you see my screen?
Yes.
Okay. Okay, so the database testing, basically the backend testing or database testing is a similar thing. Backend testing is includes everything like server and database testing is just meant for database. So the first thing I always like to ask before I start the class, that as we're doing the database testing or backend testing, what do you understand by data? What is data? I forget about testing in IT industry or anything like. There's a general concept of data. What is the general concept of data to you? That's the basic question. What's your idea?
Data is a collective data of all the information.
Collective information, a set like all the information together. We call it data, right? So data is basically information, but it's raw information. It's not processed. So, for example, if we are doing a research on something, you collect data from everybody, from your researchers. First thing you do is collect your data. Then once you collect all the data, you start processing it. You look what you need. You sort them. You like separate them based on their characteristics and based on what you need, based on what you are looking for. So the first thing you do is you collect as much information as possible. So when you are doing it, when you collect all the information without any validation, the raw information, that is called data. And once you process the data and sort them and collect all separate the ones that are necessary to you, that's your information. Just for an example, let's give a simple example. For when you are let's say you are working in an office. So you know your employees' information, or there's in the computer you have recorded all the employees' information, right? So let's say your manager tells you, okay, I want to know the employees who are making like more than 50,000. I want only the employees that are making more than 50,000 in a year. Who are those employees? So let's say there are like 1,000 employees together, and everybody's information is there, right? So that's your data. And when your manager says, okay, I want a certain part of that information, so you go and you run some kind of query, or you do however you can, like maybe you have an interface, but you process those data and bring out a processed data. So that what is necessary, what your manager asks to get. So that's the processed data becomes information. So that's our data and information. Now, before we had technology, we had computer and stuff. We used to store data in files, like papers and files. So let's stick with the employee example. If there's an organization, for the employees, everybody, they had each one file for each employee, right? And whatever his information goes into that file, and they store it into like some kind of filing cabinet or stuff. So all the officers had whoever's Online, can you mute your microphone, please? Someone's making a little noise. Can you mute your microphone, please? All right. Yeah. Yes, you're. Okay. So so I was saying that we record the organization used to have file for each employees, and so the filing cabinets, every offices have filing cabinets, and let's say stick with the employees and the employees cabinet, they had one file for each employees, right? And each file had all the informations. So if you need one information, let's say you want to know only the salary of like 10 employees, you needed to pull out those 10 files and then go through the salary and write down in a separate piece of paper, right? So that was before computer. So when computers came in, so people started digitalizing stuff, right? So scan the paper and stuff like that. But before like organized database, people were still doing as files. So even though it is an electronic form, but it's still file. It still was the same format. Like each employee had like we used to do these folders. So just for example, like folders for each employees, and over there we had stuff in the folder just like paper files, just in electronic format. But it's still, if you cannot like get your data as you want, you still have to go through all the folders and copy the information and make a separate file or something. So when the early database came in, the first database when that came in, that also was following. It started recording information. It's a database, but it's not processed information. Well, as time evolved, and people start building stuff from their need, right? So they said, okay, this is not comfortable, this is not efficient, so they found another way. So they keep improving, and right now we have our database management system where we have database and we have different database management systems and a lot of other stuff like that. So so basically, what is a database? So database is easy words. In simple words, database is the place where you store your data. So your computer hard drive is also a database for your laptop or your computer. Your database is basically, your storage, your hard drive is basically a database for this laptop. So this is also a database. It's just simply where you store all your data. But imagine if it's the company, your information, my information are not that much. We need like 500 gigabytes is enough, or maybe 100 or 1 terabyte. But imagine the organization keeps getting bigger and bigger, and you need a whole lot more space, and you need to manage the information. You need to store the information, manage the information, the data, maintain that, and in an organized way where you can bring out the necessary thing, what information that you need in a second. You can process them. You can organize and reorganize them. So to do that, we need a bigger space and a safe location, and also it has to be a robust system, because let's say if you store some data in a separate hard drive or something, a hard drive doesn't last very long. So your database has to be something that is durable. Your data can be stored over there years after years and without any corruption. It has to maintain its integrity, the data integrity, right? So basically, companies like Oracle and Microsoft, they made these databases like big spaces, huge spaces, and started to rent the space to the company, just like the apartment buildings or the storage units. They started renting or leasing this space to the companies. So other companies, they take some of the spaces from Oracle or Microsoft, and they store their information over there. Some companies have, like smaller companies, they have their local database, their local server. But most of the companies, big companies, they rent space from the big database companies like Oracle or Microsoft. So how does this work? It's similar to like apartment renting. You are leasing an apartment, you lease your apartment, you need, you tell them, okay, I need a 2-bedroom apartment, 3-bedroom apartment. Similar, you tell the company that, okay, we need this much space, and for maybe this many years, and other requirements you tell them, and you get your space. They provide your security and safety and security, and you store your you get to store your data, you get to store your information. So this is how you store your information into the database. Now, we were saying before that database is where you can store your information, your data, and you can maintain your data, you can organize your data, you can retrieve your data. If you just save it and you cannot retrieve it, then it's of no use, right? So to do that, you need some kind of management system. You need some kind of a system that assure you that you can store your data, you can manipulate your data, you can organize them, reorganize them, you can delete them, you can retrieve them, whatever you want to do with your data. To do that, you need some kind of a management system. So that management system is your data in the database. That management system is called the database management system. I think all of us are familiar with the term database management system, right? So database management system, or DBMS, we call it DBMS in short. So DBMS is a management system that allows you to store, organize, maintain, and retrieve your data from the database. Now, I think we all understand we store, maintain, and things, but how do we do that? We just said, okay, it's a kind of management system that allows you to do that. So how do you do that? Through what? How do you communicate to the database? SQL. That's where SQL or SQL comes in, right? So SQL or SQL is the language that you use to communicate with the database. It's basically, if you go to China and if you want to communicate effectively, the best way to do it is learn Chinese, right? So it's the same thing. You go to the database and you speak the database's language. Instead of simple English, you just twist it a little bit, twist and turn a little bit, and make it an SQL query. So SQL is basically a language, a simple language that is used to communicate with the database. That is our SQL. SQL is the full form of SQL or SQL is structured query language. So structured query language is the language that we use to communicate with the database, right? Okay, like we said, there are different types of database. Microsoft, MySQL, and Oracle are the two biggest one, I think, right now in the market. Other than that, there are SQL Server, There's DB2, there's Sybase. Basically, these are the major ones, but MySQL and Oracle Server, I think, are the two biggest ones. But a very simple database, like I think we all are familiar with that, and I always like to mention this one because the first thing we learned when we had computers as kids, the first thing we saw is what Microsoft Office Suite, right? In the Office Suite, there was a database there, Microsoft Access. That's actually the first version of database. Now, we know that we store information in the database and a lot of other things like we maintain, retrieve, and stuff like that. But how do we store it? We store it, but how do we store it? So when we started storing data in the database, like I said before, we started just storing it somewhere in a place. We just store it. But when we retrieve the data, it's a problem to retrieve in an organized way. But we just store something in some place. But it's just like a closet. You just open the door and throw your stuff in, right? And then you cannot just, when you need something, you have to move everything out, and then you find your stuff one by one. So that's how it was going. And eventually, day by day, it was improving, and people were getting more organized and finding new ways to organize the data and to retrieve the data in effective way, less time and much more organized way. To do that, they started making tables in the database. So to make tables, first they said, okay, we'll make tables. We'll say, okay, this person, one person, one employee, we just make one row for him, put everything over there, name, and the other cell. I'm just giving an example. It's not exactly this way, but just for your understanding. Just trying to give an example. So let's say they created a table first, then put the name, and they put everything else in another column. But this is, you cannot separate some stuff, like you cannot know, let's say you want to know his phone number. When you retrieve it, it comes with all other stuff as well. So you have to find your phone number from there. Or if you want 10 employees' phone number together, you have to go through each cells and find those. So it was not very organized. So day by day, they were separating the cells, they were separating the columns and rows, and making it more organized and more easy to retrieve format, so that you can now, like people like in our generation, we don't even know how, like, for us it's hard to imagine, like if you go and you want to say, okay, I want let's say your pharmacy, right? You want to say, okay, I want my clients, some of the clients' phone number, I want to call them, let them know that their pickup is ready or something. Probably you have one set of data that just says, okay, the pickup information, these people are in the pickup list, right? Mm-hmm. So you just go there and you find all the pickup at one place. You have some other stuff in other place, very organized, right? So for us, it's hard to imagine when people used to go through papers and find the stuff. So, but it didn't happen in one day. It evolved and came to today's position. For you have all the information in the GUI in the front end, but those information are coming from somewhere. They're stored somewhere, right? And it's coming up when you are. I think he got locked. So.
Hello.
Hey. So that's what I was saying about the tabular format. So the front end and the same thing, the retrieval of the information, you are using the front end. The same thing you are doing if you do it directly through the to the database. That's your backend testing. That's all. You're doing it in the front end. you're going through a graphical interface that is transforming to a different format. That's going to the database, bringing up the raw data, it's processing again, presenting it to you in an understandable way, right? So that it's very easy to understand. But if you skip your front end, just same thing, you just keep your front end, you go directly to the database instead of the front end to the screen, you just directly go to the database, skipping this step. But in that case, you don't have these nice options like it's not nicely organized. You have to and make him understand that, okay, I exactly need this thing, and he retrieve it you in that format. So you have to understand like how you need to tell him the language, and when it gives back to you, it will be also in the just regular, maybe a tabular format like this. So it's not like very nice. It does not have the graphical interface. So that's basically database testing. And that's basically the purpose of database testing, why we do database testing. Why, maybe you might have a question that, okay, I'm seeing it in the front end so nicely, easy to understand, it has nice colors, then why do I need to do database testing? So imagine when they created a software, let's say, let's go with the banking example. Let's say Bank of America. They always didn't have that website and the web application, right? Excuse me. In some point of time, they didn't have any website. They didn't have any computer. They were on paper, everything. So after that, they built their website, web application. They built their database and stuff. And now, imagine how important that database is. If something goes down, like the database goes down for 1 day, how much money they're going to lose? Just imagine that. So see how important it is to store the data in the correct place and the correct data in correct place. How important is that? So why do we do database testing? So I know just when you go to your bank account or Bank of America or any bank, you have a nice interface. You enter your login user ID and password, and you go to your account, and you see all the information, how much money you have. You can transfer your money. You can do whatever you want, right? A lot of stuff. But before they built that system, they had to make sure that your information is going in the right place. Let's say you deposit $1,000 and it does not go to your account, instead it goes to someone else's account. And someone else's information comes to your account, someone else's login information or security question. When you log in, you see those information. So this will be a disaster. So before they created launched this application, they had to make sure that, okay, when someone is storing something, it's going to the right place. And when someone is bringing back the right information is coming up. And the information is stored, the place this information is stored, it's contained, it's not corrupted. It has to maintain its integrity of the data, right? So as a backend tester, our job is to confirm that the data is getting stored in the right place, and we can retrieve it in the pure form. It's retrieve it, the correct information. That's our job. So basically, we are testing that the data is storing correctly, and we can retrieve it correctly, and we can retrieve it in an organized way, and we can retrieve it, maintain it in the right way, so that the data have its data can maintain that data integrity, right? So that's our basic stuff. Now, we were saying before that a data is stored in a tabular format. We create a table, just like the one you're seeing on the screen. Let's say this is a table. So these are our column names. So I was using this table just for an example. So this is let's say this is our table, and we have this columns. So this is our column names, employee ID, name, phone number, salary, like this. So we create these columns and we enter data for in the columns and in the table. So each column will represent an attribute, one single characteristics, right? So first column, let's say the column name is what? Employee ID. So this column all the way up from the top to the bottom, it will have only the ID, the employee ID. So that's an attribute. So in a database, a column is called an attribute. When someone say, okay, what is the attribute of this table? What is the attribute is called? When somebody says attribute regarding in the database, you know that he's talking about a column. Okay? And the same way, each row in a table is called a record. Why is called a record? Let's say, let's look at the table. I don't have any information in the table, but let's see if we have the table. Yeah. Okay, so look at this table. So this is a default table in the system. If you just, you can take a look at it, and you can use it as a reference to practice. So basically, this is, let's say this is just an example of your employee table, and we say that each column is called an attribute, right? So the column, each column has one attribute. This one is employee ID, first name. This column is the attribute is first name. This column, the attribute is last name, and so on and so forth. And we say that in a table, each row is called a record. So why is it called a record? So look at this. Look at the first row. It says it shows you the information regarding this employee, Stephen King. So everything in this row is about Stephen King, right? So this is a record for only Stephen King. This is a record for this employee. Similarly, each of the row represents one person, right? Each column represents one characteristic, and each row represents one person, or one unit. If it's not a person, if it's a product, it will represent the product or whatever. So if you go to the row, each row, it will be a record of that certain person or certain thing, product or whatever. That's why it's a record. Each row is called a record. So just to make it clear again, so each column is called an attribute, and each row is called a record. Now, in a database, we don't only have one table. This is just one table for an example, but in a database we have a lot of tables, not just one. They create database. They like divide it in parts, and each part they have multiple tables. To record stuff, they have multiple tables, right? So some tables, let's say this one is for employees, everything is there. But some tables, it might be only for salary. Some tables, it might be only for like personal information, like address and phone number, stuff like that. But the thing is, how are these tables connected? So this table, if they're separate tables, but you need information from 2 or 3 tables, how we can retrieve is we need to connect this table to each other, and these tables are connected to each other, in fact. Most of the tables are connected to one another. And how are they connected? So they are connected, for now, just remember that they're connected through primary key and foreign key, right? We'll go into primary key and foreign key, but for now, just remember that they're connected to each other. The tables in the database, they're connected to each other through primary key and foreign key, right? And so the connection, so there is a mapping for the overall tables of the database, right? There should be you have to know, like somebody who is maintaining the database, he should know, or he must know actually, that how is the database is organized, which table is connected to what, which table has what information, and which one is a primary key and which one is a foreign key. The person who's maintaining the database, he must know those. So for these and for other people who are using the database, for them, there is a mapping. It can be to make it easier to understand, let's stick with a graphical example. So let's say there's a graphical representation of the tables in the database, and the connections to each other are represented, are shown in that graphical representation. That is called a schema. It's very important, right? You should have a note of it. What is a schema? A schema is basically a representation of the database. It can be graphical, or it can be in different format like XML or something. But schema is basically something that describes the structure of the database, the tables, and how they're connected to each other.
It can be graphical.
It can be graphical, or it can be in any other format, like, for example, XML. So if you need to know a database, you need to know the schema first.
So it connects the tables?
Yes, how the tables are connected. It does not connect the table. It shows you. It shows you how the tables are connected to each other. That is your schema, right? Okay, so we have our schema. What else? What else? Now we state that our tables are connected to each other through primary key and foreign key, right? Now let's see what is a primary key and what is a foreign key. So, what is a primary key? Tejpal, do you remember?
Uniquely identify the rows, but it can't be known.
It can't be known. Okay, good. So, a primary key is a column of the table that uniquely identify each record, right?
Yeah, a row.
For example, in this table, this employee ID can be a primary key because the employee ID is unique for each employee, right? And each employee must have an employee ID. So if you hire an employee, you definitely will have an employee ID for him, right? So in the employee table, the employee ID can be a primary key. Now, the primary key is sorry, I was saying the primary key, right? The primary key is basically what it does not comes in the table. Like if let's say this is the employee ID, we are saying that this can be the primary ID, but I don't know if it's primary ID or not because I did not create the table. So when you create the table, you have to declare one column as your primary key. So let's say you have some kind of database or some kind of table where you have the social security number of a person. One column has the social security number. Let's say over here in this table, if you have another column over here or here that says social security, right? So we know that each person's social security will be unique. One social security will not match to another one's. So no two person will have the same social security. So the social security is also unique, right? So if this column has two columns that are unique, for example, that one is employee ID, this will be unique to each employee, and the social security number, that is also unique for each employee. But now, if you want to decide, if you decide to declare social security as your primary key, you can do that. But the condition is whatever the column is, it has to be unique for each record. And if you want to declare it as a primary key, it cannot be null. You cannot leave it blank. Okay. Now, when there is two unique columns, the one must be primary key, and another one is called unique key. So the other one is also unique, but it's not primary. Why not? If it's primary, when you declare a column a primary key, that is your only. It can be a primary key can only be one for each table. One table you can have only one column as primary key. You cannot have two columns. So when you declare one primary key, you cannot declare another column. You cannot declare it as primary key. First you have to erase this one, and then you have to declare the other one as primary key. So you have two unique columns. Just for example, let's say here we say employee ID and social security. Now if it had a social security number and employee ID is still the primary key, then the social security number column would be the unique key. It is unique for each employee, but the only difference is it can be null. You can leave it blank. But primary key, you cannot leave it blank. You have to have a value, and unique key is you can leave it blank. That's the only difference between unique key and primary key. Now let's say let's go to what's the other key we were talking about? Oh, foreign key, right? So foreign key is basically when two tables are connected. We say two tables are connected through primary key and foreign key, right? So when, let's say this employee table, you have a separate table that is called management table, right? Or let's say sales table. Let's say we have another table called sales table, right? These are the employees who sell stuff, and we have another table called sales. How much amount of sale we're making. So if we have a sales table and we want to know which employee is selling how much amount of product, then we need to connect this employee table to the sales table, right? Because the other table will only have sales information. But we want to know that which employees have sold how much. So we need to connect those two tables. In that case, you see this employee ID, we said this is the primary ID of this table, right? So you have to have this column in the other table, the second table. And when you have this primary key in the other table, in the sales table, this column is in the sales table, this column will be called a foreign key. Do you understand? Clear? Yeah? Okay, so like I said, let's say we have a sales table. Oh, there's an example somewhere. Let's see if I find it. SQL, right? SQL. don't know how I always lose this one. SQL. Okay, let's take it to this now. I'll go over that when we go to the other thing. So I was saying that, okay, the employee ID over here, this is the primary key. We said this is the primary key in this table, right? And if we have a separate table, a different table called sales table, and we want to connect these two tables together, then we must have this column in the other table as well. So when this column is in the sales table, it will be called as the foreign key. In the sales table, the employee ID will be foreign key. Over here, this is primary key. In the sales table, this will be the sales table. This will be the foreign key. And in the sales table, there must be a primary key in the sales table, right? So the sales table, we will add it here to connect these two tables. We have to add that primary key in this table. Let's say that is sales ID. So if the sales ID is in here, another column we will add called sales ID. So the sales ID will be foreign key in this table. But in the sales table, that will be the primary key. So basically, one table's primary key is another table's foreign key. Simple as that. Now, another thing I want to go over is the normalization, and then we'll start writing our queries. Anyone have any questions so far?
Is there any composite key?
There is a composite key, yes. It's basically, it's like, we can skip it for now. Composite key is basically, yeah, two different attributes in one table. So we'll go over it later sometime.
So at some point, it's gonna go to the job, it's gonna ask you to do normalization.
Very unlikely. If you go as what do you call it, backend developer, only then. Hey, that's okay. How are you? Good to see you. Hey, how are you? Long time. Yes, I did inside. Okay, guys. So, okay. So let's go in the normalization. Like I said, I lost that thing. Just hold on a second. Let me find out my Excel sheet. Give me a second. Okay, I think some of you have went through this over and over, but let's go over one more time. So normalization, basically, remember I was talking before that how they're organized, how they're starting organized the tables. So this is just a simple example of how they came up, how they evolved, and how we came to today's structure of the database. So any people online, if you have questions, please feel free to stop me and ask your question. So I don't know why it's not going up. Okay. So this is an example of the early database. And in the process they evolved, it's called normalization. So basically, this was, let's say, an early stage of database. So like I was saying before, that it was not very organized. So let's say that this is an example of a movie rental, just for an example. So we have the movie rental, they wanted to track their stuff. their business. So they created a table where they have their customer name and their address, whatever movie they rented, and sorry, what type of movie they're rented, right? So they created a table. They entered the name here, the address, another column, movie rented, the salutation, and this should be actually in the front, but let's leave it for now. And the category, what kind of movie they're renting. Notice that if there is two person called here, there's two person called Derek Jeter, the same name. So if you want to find Derek Jeter, maybe you can just say, okay, let's find Derek Jeter. Then you go and there's a big chance that the employees will make mistake and put his stuff, put this person's stuff in this column, this cell, and this person's stuff in this cell, right? There's a big chance of that. Also, you cannot if you want to like bring up movies, then you cannot bring it because it will come together. So he only rented two movies, but as time passes, more and more entries will go in the same cell, right? So you cannot separate them. When you bring them up, all of them will come up, and you have to separate them manually. So that's a time-consuming process. So this was a drawback. So I said, no, it will not work. So let's find out a way to make it more organized. That is called the process I said that it's called the process of normalization. So the normalization, the first thing that we said, okay. So let's do the first normal form. It's organized later, but it's called the first normal form. The first normal form is said, okay, no more than one value can be in one cell. Okay. So let's go to our first normal to see how it looks like. So basically, it says, okay, each table cell should have only one value, no more than one. So now each cell must have one value. So you have to have separate cell for each movie and each item, right? So now we have to create. Now we created a table for each movie. We created a separate row, right? So now it's a little more. Now if you wanna like copy something, if you wanna organize something, it's easier because it has a little more organized, because it has each cell have one value only. So you can copy this and take it out or organize it the way you want. But there's still a problem now. As you have a separate record for each movie, you have more of repetition of the name. See, before it was only one stephigraph. Now we have two, and that one you had two before. Now we have three, so it's more repetition. So when you bring out Derek Jeter, there will be three records, and you still have problem. It's still hard to organize and identify the customer. This is a small one, so we can say, okay, we can separate them by address. But imagine a big one that has a lot of them. So it will be very hard for us to identify them.
But it also changes the address for every single person.
What if we change it?
No, it's changed already. Like for a step.
Oh yeah, this is just a mistake. Probably when they create, they just copied. It should be the same. It's the same person. Because we just separate the column. These two. I heard one record, and the other one record. Yes. I'll keep it this way, but actually this is a typo. So basically the idea is these two person are from the first one, the 500 Duke Street, and this one is this one, 100 River Avenue. So Oh, okay. So like I was saying that it's still hard to retrieve the data correctly. So now we said, okay, it's still a problem. Let's find out some other way. Let's make it more organized. How can I do that? Now we come up with that unique identifier thing. Okay, so and it's so this is the first normal form, right? Now we said, okay, the first normal form is good, but we still have to have a little more than first normal form to make it organized. So we said, okay, let's do second normal form. Okay, what is the second normal form? Second normal form, you have to make it first normal form. So it has to be each single value in each cell. And the second thing is you add a unique identifier for each record. Now we have a member ID column. So the member ID column, remember we were talking about primary key. So as this is a unique identifier and none of these are blank, we can declare it, we declare this as a primary key. So this is our primary key and this is a unique identifier. So each member has a unique identifier, ID number. So like we were talking about before, our employee ID. So now we have a customer. Each customer has, when they sign in, when we enter them into the system, we assign them a unique identifier, so that we can identify them easily. Now, Derek Jeter, no matter how many times he is in the table, we still have him. Okay, number 2. We know that this is the person. Okay, this all if he is in the 10 times, but still it's the same ID, so we know that okay, this is the same person. We don't have to go through all the address and stuff to make sure. And then sorry, yeah, and the single column primary key, we already said that. So first thing is it has to be first normal form. That is, it has to be each table cell should contain a single value. One cell cannot have more than one value. And then we say, okay, each record needs to be unique. How do we make it unique? We add a primary key. So now that, look, we have to break this table into 2 tables because of what? How can you make this each record unique? If you say, okay, here, if somebody else takes Titanic, then it will be a repetition. So we broke down the table into 2 separate categories. One, we said, okay, this is the customers table, only customers will be here. Each customer is unique. And then we've made a separate table called movie table, and each movies are in that table. Now when we retrieve the information, we just connect these 2 tables and all the related information will come up. Now there's still one problem left, which is called a dependency, a transitive dependency. What is the dependency here? Look at this column. In the customer member table or customer table, look at this column. This column, now if this person is, instead of Steffi Graf, this person is someone else, Steffi Graf. What is the other guy's name? Novak Djokovic or Rafael Nadal. So if that is the name, then what happened to this?
Mr.
It becomes Mr. So this column actually depends on this column, right? So that's a problem too. How is this a problem? So when you change this one, you have to change this one. It cannot. It will be a little complicated when we start bringing our stuff up when we retrieve the information. So this is the transitive. This is called the transitive dependency. So this is the definition, but more important thing is for you to understand. So transitive dependency is when changing a non-key column might cause another column to change. So to avoid this thing, we do another normalization, and the final one for us is called the third normal form. So in the third normal form, we say, okay, just basically just avoid transitive dependency. So how do you do that? You just separate that to another table. That's all. For the salutation thing, you make another table, and then when you connect it, just connect the three, and you will have your stuff. At the beginning this might be a little confusing, but just keep practicing. This should be easier with time. Any question regarding normalization? I'll take that as a no, and let's move on. Okay, now this is our Oracle database, SQL commands. I would recommend each and everyone to get this software. This is Oracle 10G Express Edition. You cannot get it by yourself from Oracle now because it's outdated already. 11G is a little, you can get the Express Edition 11G, but that is a little different than this one. So for practicing, this one is better, and if you get it from, I think you guys already have it, right? Did your one work?
No.
It did not. Oh, okay, so you have to have a Windows computer?
Yes, I have Mac Pro, so that's my
Okay. Yeah, so let's try to get it as soon as possible, but without practicing this one, it's actually not much of help, because the theoretical stuff I'm saying, it's you can remember those, but if you don't practice it, your main goal is to know how to write the queries. So it's better to have the software. So this is, like I said, this is Oracle 10G, and whoever have it, you already know how to go to this page. I just opened it, and we will use this table as our reference, because this one has a lot of information and we can do some manipulation in there. But before we start writing, I just want to go over again through the different languages that we have. I think most of you already know that there are basically three different kind of different types of SQL query. The DDL, or data definition language. We said data definition language has to do with the structure of the database. Sorry, not the database, structure of the table in the database. So DDL, basically whatever you do with the structure of the table, like for example, creating the table, changing the structure of the table, removing the table from the database, stuff like that. These are called DDL. Again, it's data definition language. So you are defining your table in the database. That's data definition language. The second type of SQL language is called the DML, or data manipulation language. So from the name, you can say that, okay, data manipulation, you are manipulating the data, you are changing the data, you are updating the data inside the table. Now, you're not doing anything with the structure of the table. Now you are changing or entering or deleting or updating the data inside the table. Nothing to do with the structure, right? And the third type of language is called transaction control language, which is basically an admin stuff. It's when you, well, no, actually no. Transaction control is when you do commit and rollback, those kind of stuff. Like commit is when you write a query, you need to commit it to be recorded. Like over here, you'll see this checkbox. It says auto commit, right? So auto commit is when it's selected, when you write something, it's directly saved. You cannot just remove it. You have to remove it to write another query to remove it. But when this is not selected, and you write a query, it will not directly record it. You have to run another command named commit. Only then it will get saved. So these things are called transaction control language. So whatever transaction you're doing, you need to control it. Okay, but transaction control, we don't really use them much. Also, DDL is also, just to clarify, DDL is also has to do with the structure we were saying. So DDL is, as a tester, our primary part is DML, or data manipulation language. That's our primary goal. But you must know some DDL to have some idea. And I always mention that depending on the organization you will get a job, you might need to do some structural stuff as well. Because if it's a small organization, there are only a couple of them, a couple of testers, you might need to do a lot of stuff other than backend testing. Some of, like, maybe you need to do some of the creating the tables and stuff like that. So you must know the basic DDL stuff, and if you find it interesting and if you want to know more, that's very good, even better. Having said that, let's start writing our queries. So first thing we will do is we will create a table. Creating a table is what kind of language? Is it a DDL, DML, TCL? DDL, right? Great. So to create a table, it's the keyword is create. So here is the syntax for create. Create table, table name, column 1, data type, limit. You can call it anything you want. I'm just giving you a general example. Let's make it short. Column 2, data type, no comma, limit, and goes on. Goes on this way. You have to have a comma after. Keep going, and that's it. So that's our syntax, general syntax for creating table. So let's create a table then. I said the syntax is what? Create table. Table name, right? Table name. Let's call it, I know there's a lot of FT, FTech. It's already created in this one. Let's create a different one. Let's create QA, whatever, QA 2. Okay, that our table name is QA2, right? QA_2. Let's skip the 2. It will be easier for us to type. And we have the column name, right? So the first column, like over here, employee ID. Let's keep it employee ID. Let's just call it ID. ID. So our first column, I want to be the ID column, and ID column, ID is usually a number, right? So our data type, the data type will be number. So people who are not familiar, there are basically three major data types in when you are using Oracle. One is ID, number, worker 2, and date. So these are the three major data types. So number it's all number, worker 2 is alphanumeric, and date is date. This different version of SQL uses different date format. This one, I think it uses, I'll show you the format
If you want to make it easy for yourself, can you just do all bucket rules if you want?
All do what?
Can you do bucket rules, all of them?
You can do bucket to all of them. This has to do with the storage. So it's not technically it's correct. It will be like the database will accept it. The system will accept it. It will not have a problem. But it's prefer. I mean, the standard is when there's ID is always going to be a number. So you just keep it a number. It's the standard. But it will even if you give worker, because worker is alphanumeric, so it will still work. So ID we said what number, and how long do you want it to be? Let's stick to 5. So when I say okay, the limit is 5 digit, what does that mean?
So only 5 plus.
It can only be 5 digit. It can be less than 5 digit, but it cannot be more than 5 digit, right? Instead of limit, you can call it size or whatever you want, but basically it means the same thing. So our first column, so we defined our first column. This is not right, it's a comma. So we separate, first we write the name of the column, this is the name of the column. So first we say, okay, this is my column name, and this is what kind of data this column will have, and this is the limit. This is the limit. This can be 5 digit or less. So that's first thing. Our second column, let's call it first name, like always. First name will be what? I said first name will be an alpha, right? So it's a worker, right? Worker 2. And first name can be, let's say it's a 30 digit number. First name 30 character. This is our second column. Guys, hold on a second, please. Okay. Sorry, I did not see your chat before. So yes, to answer your question, the multiple foreign key could be in a table. Yes, when there is one table is connected to multiple table, there will be multiple foreign key. But primary key can be only one. But if the table is connected to three other tables, then there will be three foreign key. It must have three foreign key if it's connected to three other tables, because the primary key from each table has to be a foreign key in this table. So that's why it has to be three foreign key. And I didn't really get the question about the green pump. So if you can elaborate it later, maybe we can discuss it later. But let's go back to our query. Okay, so we were, sorry for the interruption. So let's go back to the creating our table. So we said, okay, our first column is, we called it as the ID column. Oh yeah, database. Yeah, there are different types of database. There are multiple databases, but I'm not familiar with this one. The green pump, I'm not familiar with this one. But there are a lot of databases in the market, but the major ones, I don't think this is a major player in the market.
Green pump database?
That's what he's saying. I don't know this one. But thank you for sharing. I learned a new thing today too. So yeah, it's everywhere you learn new things every day. Oh, yesterday I learned a new thing. Let me just share with you. So there was I was in a meeting and somebody was saying, okay, we'll do the dirty testing. I was like, what is dirty testing? So what do you think is the dirty testing?
I don't know. It's smoke testing. Like starting, we do.
Basically, it's a smoke testing, but it's just okay. It's not organized. We just go and do some random testing. You're not familiar with anything, and yeah, basically it's an ad hoc testing. But as it's not organized or anything, you just go and do, like, it's the first time you're testing, and you don't have any documentation, nothing. You're just going and doing smoke testing or ad hoc testing. Okay, it's bigger than Oracle. All right. I'll have to do some research on that then. Clearly. Thank you for the information. Okay, so let's go back to our creating table, right? Okay, so this is our, so we said, okay, what create table, the table name we call QA, column ID, the first column is ID, data type number, and limit is 5, second one is first name, worker 2, limit is 30, third one is definitely, if there is a first name, there must be a last name. Yeah, he's in the room. Yeah, you can wait in that room. He's in there. Yeah, he'll be with you. So last name, and this will be also, as this is name, this will be also worker 2. Let's stick with 30 again. What else do you want here? Let's say start date, so that we have a date column. So date is data type is also date, and it does not need a limit. And what else you want? Phone. Worker 2. Limit is 15. Okay, so let's go with this for now. So we select the line, select the row. So whichever command you need to run, you need to select that, highlight that, and then you click run. Okay, so it's a table created. It is showing us a table is created, right? Let's see if the table, how was the table created? Okay. Now I forgot to declare the primary key. Let's create another. Okay, let's look at this one first. Okay, so this is our table. Let's look at the table structure. Describe QA. Okay, so this is our table. This is how it looks like. These are the columns that we created. Columns ID, first name, last name, start date, and phone. So these are our columns. Now, see, I did not do the
Friendly.
well, ID is usually ID is, we know that it's gonna be a number. ID is a number. If your ID is anything other than number, you can definitely declare it as a car or worker. You can do that. But generally ID is a number data type, so that's why we did it as a number. But it will work as worker as well. So okay, so I was saying that I did not declare a primary key in this table. That's why see all the columns are showing as nullable. You can leave any one of them blank. But right,
The error. I got the error.
you got an error.
Missing right parenthesis.
Look carefully, somebody. If you miss a little something, it will be.
Does it matter the capital letters?
No, capital doesn't matter. Yeah, this is a good question. So basically, generally, it's not case sensitive. You can use uppercase or lowercase. But if it's a name and if it's information in a code, then if it's uppercase or lowercase, it matters. Other than that, it does not matter if it's uppercase or lowercase. Probably you miss a comma or something somewhere.
Last two brackets like.
Yeah, because it's the first one is for this one, and the second one is for the whole thing.
Yes, great.
Good? Okay. Great. Okay. So now, like I said, I forgot to add the primary key. So we can do, when we are creating the table, we need to declare this as a primary key. So let me show you when you create it. When you do the ID and number, the column name and number, you just need to say, when you are creating, you need to declare, let's say the ID is our primary key, right? Then you just, after the data type, you just say, okay, not null, primary key. But this will not work now because we already created. I'm just showing you how to do it. But this will not work now because we already created it, right? Now what we have to do is alter this table. We have to write another query. So when you are creating the table, you can declare the primary key this way. Whichever column you want to be the primary key, after the data type, you just say primary key, not null, primary key, right? And if you forget, like me, just I did, you need to do what? You need to enter the, you need to declare the primary key later. After creating the table, you need to alter the table. Remember we were saying, the update the structure of the table, right? So alter table is also a DDL, also a definition language, right? So we are altering the structure of this table because the primary key has to do with, we are changing a column, whole column, the structure of the column. So this is an alter statement. So altering the table, it's alter table. The table name is QA, and we say we're doing what? We are adding primary key, right? So we just say add primary key and then column name. I think that should be it. So again, you say alter table, table name, and then you say add primary key, and then in the parentheses you write the column name. So our column name is ID, so we just say ID. If it's employee ID, student ID, whatever, this will be in the parentheses. So here we have altered the table, altered, right? So it says okay, it's successful. So let's describe the table again to see what changed, if it changed and how it changed. Now look, okay, success, right? The ID, primary key, now it's showing that okay, this is the primary key. And before it was nullable, now it's not nullable. So we declared our primary key. So like I said, if you are doing it when you are creating the table, you just need to say okay, after the data type and limit, you just need to say okay, not null, primary key. So that's how you do when you create your table. And if you forget to declare your primary key when you're creating the table, you just later, after creating the table, you just alter the table by this way: alter table, table name, add primary key, in the parentheses, column name. Okay.
So how we gonna describe? We have to give the command that describe QA. Then it will come the whole table.
No, describe QA or describe table name. It will show you this, the structure of the table, all the columns, how long are the columns, and which one is the primary key. This is the,
because it's not showing me, so I have to write that one, right? Then
it will not show you until you run this one.
Okay.
Okay, so now that we have our table, let's look at the table itself. This is the structure we are looking at, and if we want to see how the table, we know we haven't entered anything in the table, right? So it's a blank table. Let's see how if it shows anything. Select. This is all. When you say asterisk, this is all. Select all from QA. So when you want to see everything in the table, the whole table, you just say select asterisk from table name. So asterisk in all the database, and sometimes not in the database only, some other places also. When there's something said asterisk, that means all. So you select the structure, query, and run. So no data found because there is no data in the table, right? I want to spend more time in DML, data manipulation. But let's enter a few data in the table. So when we enter the data, enter is what? Insert, right? Insert is the statement for entering data into the table is insert.
This is DML.
DML. It's DML because you are entering now. You're not doing anything with the structure. You're manipulating the data. You're entering data. Yeah. So let's enter a data. Insert into to be specific. Insert into, and then table name is QA values. Start parenthesis. So the generic structure is insert into, and then table name, and then values, and then you start your parenthesis. Now you have to follow the structure of your columns. So remember, we created the column. The first one is ID, right? So let's say the ID is 101. As we have 5 digits, we can go over this. 101. So that's our ID. Second column is called first name, right? First name. What do you want to call it? John. Then last name, whatever, John Smith. And start date. Start date. Okay, here is Oracle 10G. Use this format. 1 Jan 1999.
So each database has different formats for the date.
Actually, I used Oracle most of the time. So this one is used this format, but the 11G for used with the slash. The next version of this one, the Oracle, but it does not use this format. It uses slash. And then the last one is phone number, right? So 571 5555. Right. Have a good one.
Yeah.
Glad. So you see this family, they both were a student here. You met her, right?
Yeah.
Yeah, the guy, he was here before, a few years ago. Both of them got job. What else we have? Oh, let's run this first. Okay, what's the mistake?
Maybe. What is it?
I did this one on purpose. you guys already did this.
I think we made the asterisk on the top of
The code mark. You got it. Yeah. So when it's a worker, you need the. Is it a single quote or double quote?
Single.
Single or double?
Single.
Okay. Okay. Let's do single first. If it works, then we know, right? So this is date. We don't do need date. We do need code for date.
No, we go for the name.
First name, last name. But what about date?
No.
No. Okay. What about this one? This one we probably need because it's
Phone number.
not phone number. There was a worker. Okay. So let's run it now.
For date two, name for date one.
We need for day 2 now. You said no, right? Okay, good. Yes, we need it only for number. You don't need it. Okay. So now we know that. Okay, for the new ones. So when you are entering a value, if the data type is number, you don't need to put a code mark. Other than the number data type, all the information in the column you need to put a code mark, single quote, before and after the data. So date. So this was I entered this as a worker because of the dashes. So this one also is having a code, right? And this does not need a code because it's a number, so this one does not need a code. So we entered one row in here. Let's run it. Let's see now how does it look, the table. So select table, select all from QA. Okay, here's our one row. That's how it looks like. You see, you converted the 1999 to only 99. Now let's say we made a mistake. Instead of 1999, this one should be something else, right? This one should be actually, let's say it's 2000. So in that case, you need to update, right? Okay. Can you help me?
Yeah, we want to update the value. 99.
Yeah, let's say that the date was wrong. It was not 1999, 2000. So we want to make it 2000.
And update.
Update.
Table name.
Table name is QA.
Name. Set column.
Name.
Update QA.
No, not.
Then we have to set the column. Have to put a column mark.
Okay, so go ahead. Update QA. Just tell me what way, right?
Okay. So we just want to change
Yeah, just change the date. Yes.
Date.
Mhm.
Okay. Column.
Column.
Yes. 01 John.
Column date.
And column date.
Column.
So
No, I think there is something else, right?
yeah, the column name is date.
Okay, column name is date. What's the date? There's something else. You're missing something. What we are doing? We are doing what? We are updating, right? So we are after updating what? We are updating the table, but we are doing what? We are setting something. We are setting the name, right? So set.
Okay.
Remember?
Okay, table set.
Column. Now column name, right?
Column name.
Column name is which is date.
Date.
Okay.
And new value.
New value is what? Date equal to? There's an equal to, I think.
Yeah, the column name equals new value.
Column name equals. So column name date equals new value is what?
New values.
Let's say it's the same thing. 1 Jan. Just because instead of 99, it's 2001.
Yeah. Why unique?
Where
Unique column. Where unique column.
Where unique column. Unique column is what? ID equals 101, right?
Yeah.
Is it correct?
But we don't have any column.
Start date, right?
Start date.
Yeah. Okay. So okay. Right?
We are not missing the column. We shouldn't use any parentheses, right?
I don't think there's any parenthesis, but let's run it. If it shows you error. No parenthesis. Okay. Okay, so that's how you update if you make any error inside. That's how you do it. So this is your general statement is what? Update. I'll just write the generic statement. It's update table name set column name equal to. So if it's whatever it is, if it's a number, then you don't need the quote. But if it's a worker data type, then you need the quote mark and new value, and then where unique column equal to whatever the value is. So that's our generic statement. So if you need, now let's do it one more time just to make sure that we understand. So now let's say we updated this row, right? So let's run it and look. Let's see if it really updated. See the date, we had 99, now it's 01, so it got updated, right? Let's do one more time just to make sure that we understand it. So now we already know it's update table name set. Now let's change the phone number, right? Set what? Phone equals phone number is we entered is a worker, so it will be a code. Let's say 703. Let's stick the rest the same. Now you put a condition. So by saying this update QA, we are telling the database which table we are working on. So update QA. So you know the database know that we are working on QA table. It goes to the first is goes to the QA table. Then we are saying okay set phone set. Then we are saying set phone. So it knows that okay it's in which column? In the phone column. That's our second thing. So we are saying that in the phone column enter this value 703,555 this value. Enter this value. Now it knows enter the value to this column, the phone column, but still it does not know which row it is going on. So to tell the database which row the value is going on, we have to do what? We have to let it know that okay, set this value to this row where the row is where the unique ID is. That's why we need the unique ID, where we are putting the condition where we're telling it that okay where it's ID equal to 101, right? So now it knows that okay I have to look for the row where the ID number is 101, and in this row I have to change the phone number to whatever the value is. If it's blank or whatever it is, I have to remove it and enter this number instead, and in the where in the phone column, and it is going to be in this table, QA table, right? Okay, so let's run it. Oh, this is another thing, the semicolon after the statement. In Oracle, it's not mandatory. You can use it or you cannot. You can do it without it. It does not affect. But it's just generally you have a semicolon after the statement, so it's just a habit. That's why it comes up. Let's run it. Okay, row updated. Let's see if it's really updated. Yes, it did. Okay. Now let's say, okay, I want to delete something from this table. I want to delete the phone number now. The phone number, my phone got disconnected and I did not get a new phone. Delete? No, you're not deleting the table. You're deleting from the table. So delete from QA, right? If you say delete QA, the whole table is gone. Okay, so delete from QA.
Where phone number is?
Where phone number is? If you say where phone number is, no, I don't think it's where phone number is.
Where phone number is good. Or you need column equal.
Delete from QA. What you are deleting? First, you need to tell what you are deleting.
Phone number.
Okay. Okay, let's try. Okay, so yeah, what is that? Oh, QA where?
Phone number.
Phone. It's phone, not number. Right. Okay. But this will delete the whole row.
Where to go with the column?
Let's see what it does. Okay, that's why I like to run everything. Okay, phone equal to this, right? Let's just copy it from here. So if you want to delete a record, then this is the one row deleted. See, so this deleted the whole record. Select from all from QA. You will see no data. But as we already have our structure, we can just run this one, and we'll. Oh no, we already have that. We just need to run this one, right? Run, and we'll have our. There you go. Okay. What time is it? Let's continue just so we'll finish early. Okay, let's go to the other table we were seeing before, and that table have a lot of data. Select all from employees.
So
how do you delete the value? I think it says from QA. Delete from QA.
this is another job.
This is not this one we just saw, right? It's deleting the whole thing.
Do we have to mention the ID?
Mention the. No, to delete where? No, this is the condition we are saying. This is the condition. Actually, I kind of forgot this one. Phone. Where ID equals. I think this is the one. Let's run this. It's still deleted the whole thing, right? Select all from QA. Run. Yeah, it deletes the whole thing. Insert. Okay, let's insert into. Okay, I think. Oh, great, Mustafa.
I think we have to do truncate.
Truncate will delete all the data, right?
All the data.
Yeah. Okay, I'll just run. Let's run his phone. Right. Okay. So I did it the other way. That's why it's not coming up. ID 101. Delete phone from QA where ID equal 101.
Good luck.
Okay, actually this one's this I think this is the way it should be. Five, which one was this? 571, right? Actually, it will be the whole thing. From QA, so there's a different way. I don't own. Let's use equal. Let's see how this works. But we'll come back to this one a little later.
Well, what are we going to do then? We're just gonna delete the phone number and keep the row?
Yeah, the row, yeah.
Like delete from the form that I have here is the structure here. Then delete from QA. QA, which is a table name, right? Where a unique column. So you have to write unique.
No, the unique column is the column that is ID is the unique column here. So
the ID
it generates, yeah. But that what?
We can do it by updating too.
Updating, right?
Here.
Upgrading it.
Yeah. That's another way. But update is really change. It will change because this is only have one row. We do it update column, right? Yes, update column. Yes, we can do that. Okay, let's do it. Tell me. You have the syntax?
Update QA.
Okay, update QA.
Set phone.
Set phone
Equal to
0, right? Equal to blank. No.
it's two single quote.
So just leave it blank. Yeah.
Where ID equal to
Phone equal to. You just say okay. No. What if we say null? I think null will work too.
I guess.
Where ID equals 101. Let's try this. Yeah. If you say it in null. Oh, this is the other table. Okay, so this is our by default this table is in the database, and we are going to use this as our example to run a lot of things. So as I said before, data manipulation language is our most most thing we need to do. That's our primary focus.
Can you do little down? You want to see that one? No, how we change that? The phone number?
Oh, the phone number. Oh, you just update instead of delete?
Update.
Yeah, we just update it. But delete, there's a command for delete. I don't know, not recalling right now. But this way you can do it this way too. Just remember we did update before. So instead of putting a value, you just say null. Yeah. So we were saying, okay, so this table, right? So basically our prime statement is the select statement, right? We need to retrieve, our primary task is to retrieve data. We need to check that the data that we saved in the front end, if it's saved correctly in the back end, and when we are retrieving the data, the correct data is coming up. That's our primary focus as testers. So let's do some of the select statements, and we are going to use this employee table for our reference. So the first select statement we already used a few times, that select all. If you want to see all the information in a table, you just select all from table name. Select all, the asterisk stands for all. So that's our statement, select all. Now we want to see not all the information, we want to see some processed information, some selected information. First of all, let's see a single person, right? So select, we just, like we did before, we just put a condition. We say, okay, select this and this, whatever the information we need. We just say, okay, so select this and this, and we just put a condition to let the database know that which information we are looking for. So it goes there and sort the database, sort the table by that, and bring it up to us. So let's say first thing we want to see is select, let's say one person's information. We want to see one of the person, right? So if you know, let's say you know the employee ID, you want to see see an employee's information, just one employee's information, and the employee's name is what? Okay, let's go to John Chen. Okay. So we want to see John Chan's information. Select, we want to see everything about him. So it's select all from still the table name. So we are telling the table that, okay, database that, okay, we are going to where?
Yeah, right.
Employees, right?
Yeah.
That's our table. Oh, employees. So first we are saying that, okay, this is the table we are going to select all from employees, but now we don't want to see everything. We have a condition. The condition is where first name, we are looking for a specific employee. His name is what? John Chen, right? John, last name equals Chen. Okay? Is this correct? Is it correct? Anyone? And
yeah.
Now it's correct?
And or you have to put something like that.
Anything else?
No.
What about the code?
Oh yeah. John Chen. We have to put code.
Okay, let's just try without the code just to see. So this is a good part. Just to see, let's run without the code and it will give you an error, right? John last name. So when we are searching, if it's a name or anything like that, if it's an worker data, then you need to put the code after the whatever the condition is. In the condition, you need to put the code mark, right? Now let's run this. Well, there you go. So we have our information from what's the question? If there's an existing table, how do you know? Okay, you do describe table. If there's an existing table, you just do describe employees. So, sorry, describe employees. This will give you the structure of the table. There you go. So here's your data type. Here's a length. Which one is a primary, unique? Everything's here. And that's you have all the information about that. And if it's a name or if it's any kind of like alphanumeric number, then you already know that this is a worker, because Oracle uses worker 2, so you already know. Anything other than number, remember, anything other than number needs the code mark. So if it's not a number, pure number like ID or something like that, salary, then it will most likely it will need the code. Okay, so there it is. Oh, that's how we said, okay, we want to see this information, right? This person. Now, if this is the name. Now, if we know only the only first name, then we will not have the end, right? So we will say, okay, the first name is John. There might be, we just know the first name, so we say, okay, first name equal to John. In this case, there will be, we have three John in the organization. Now let's say you need a phone number of somebody. I said, okay, find the phone number of this person. Let's stick with John Seal. Yes, select phone number from employees where
first name is John.
Okay, where first name equals John. We know the last name as well. And
The end doesn't have to be uppercase or lowercase.
no, I put uppercase just to focus on it. Just okay, we are using end. If it's in the code, it has to be exactly the same. Other than that, it does not matter. Last name equals, I said SEO, right? SEO. So you will have the phone number. Okay, we just said, okay, I just need to know the phone number, so it's just giving me the phone number now. Before we said we want to see everything, so it gave us the whole record. Now we just said phone number, so it's just showing phone number. 230. So Nita, are you getting it? Is it okay? Good. Because I think you were the only new person in this.
I was doing this employee first name. It says no data found.
Which one you were looking for?
The first name and John and thing, like from employees.
The same one?
Yeah, the first one we did.
Okay, probably you missed something, a comma or something. So it's select whatever column you're looking for. That first, yeah, select whatever column you're looking for from table name, where, and then you put the condition where first name equals and last name equals. So we have here two things we know. That's why we're using an and, right?
Yeah, but the
Same thing is not coming up. See if you have employees. You have the S after employees. Sometimes that happens to me. I miss the S at the end. Oh, just another term I remember. Just it's not related to the class. Just I was saying before, dirty testing. Any one of you have heard the term monkey testing? Yeah. Okay. Okay. That's another thing I learned recently.
what's that one?
I didn't know about monkey testing. It's jumping like monkey from one thing to another. Yeah, so the terminologies are kind of a lot of things you learn. Like every day you hear new terminology, and most of the things you already know, but you don't know that it's called. It has a name, a weird name. So basically that's it. You got it? No? Okay, I'll
Let me see phone number.
Guys online, hold on a second. Sorry. Select phone number from employees where first name.
Yeah, I will try without the phone number. Extra distance.
Last name. Oh, yeah, this is the thing. So remember I said if it's inside the quote, it has to be exactly the same.
Inside the.
Here, you see the name over here?
Mm-hmm.
When it's inside, anything inside the quote, it has to be exactly the same. So the name, look in the table, the name, the name is written in this way, the name is with capital letter.
First one should be.
Yeah, so you have to write it this way. So when it's inside the quote, it has to be the uppercase and lowercase matters. It will not work if it's not exactly the same. Okay, so these are kind of easy. So you just say, okay, select this from table where this. But I mean, select statements are fairly easy. It just you need to convert the general statement to your database statement. Like for example, let's say I'm not telling you just a simple one. I'm telling you, okay, I want a list of the employees, all the employees who are making. There in this table there are some employees who have a commission. There's a column called commission percentage here. So there are some employees who's making commission. These employees are making some commission, and the rest are not making any commission. So I want to know which employees are making commission. So I'm telling you in general statement, you just needed to convert into your database language. So but it's still fairly easy. It's still the same statement. You just need to understand, need to convert what I'm looking for and what you're looking for and how to write it. So let's say we want to know all the employees. We want a list of all the employees who are making commission. So I want to know the names of the employees who are making commissions, right? So okay, any idea? It's still select. Sorry, it will be still select, right? Select. Let's say I just want to know the name, right? So if I just want to know the name, then I will say okay, first name and last name, right? First name, comma, last name, from table name employees. Now I put the condition at the end where, what is our condition? Condition is commission, people who are making commission, right? So we know that the column name is what? Commission percentage. So our column is where commission underscore PCT. That's our column name. What is the condition? Commission percentage. There is some kind of commission, right? So it is, we're saying that okay, it's the commission percentage. What do we call this? These things we call it what?
Null.
Null. So if we're looking for someone who makes commission, which is what? Not null, right? So this is just it's used in the database. These are the common statements. So null and not null are two of the operators. So null is if any of the column is blank, it's called null, and if it's not null, if it's not blank, then it's not null. So these are two of the operators. So we are looking for people who are making commission, so their commission will not be null. So there is not null, right? So let's, oh, is not null. I think it's is not null. Is not null. So we just run it. Okay. Okay, so these are the people who are making commissions. We actually did not. We should add the commission percentage as well, just to make sure that they're all, none of them are null. So we add another column called commission percentage, and we say okay, run. Okay, so now we see all of them have commission, and see we have 35 rows, right? So 35 of the employees. Now if I say okay, how many employees, you know right away that okay, 35 employees are making commission. Now let's say I want to know write the opposite one. I want to know who's not making the commission. In that case, it will be what? Everything is the same, just
Not will be removed.
not will be removed. Exactly. Very good. So now we know that they're not making any commission, so their commission percentage column will be blank. So it is null, right? So we just say okay, the commission percentage is null. So now we see okay, all of them are blank. So see, none of them have any commission percentage. Okay, that's great, right? So these are called operators. This null, not null. There are multiple operators like this. There are two kinds of operators. One is called logical operators. Another one is called comparison operator, right? So logical operators are the numbers. Sorry, not the numbers. Are the words like null, not null. There's other who is like. Let me write it down so I can. Logical operators like, in, between, what else? And or is null. Oh, you guys all have the Okay. So it's no point of writing it then. You already have all of them. Nita, do you have that paper? You can find it. Is it this one? Okay. Are you added in that group? Okay. So just go to files and search for SQL's syllabus. Yeah. Okay, so you already have it, no point of writing it. But so these are called the logical operators. So these are basically these. The condition, when we're putting the condition, this helps us stating the logic to the database. So we're telling the database, okay, this is null. We're looking for the information that where the column is null. We're looking for this or this. We're looking for this and this. So these are called the logical operators. The other one is comparison operator. Those are like mathematical signs, bigger than, greater than. I think if you have that, you already have that. For NIDA especially, so these are basically the mathematical signs. So equal to or not equal to. This is how you write not equal to in or this two-way. These both are not equal to, and you say bigger than, or you say smaller than or less than, right? No, I think one of them are wrong. This one I think after, right? So these are your comparison operator. These things do what? They compare to the numbers you're looking for. Let's say you're looking for something. You're looking for salary less than 20,000. You're looking for the people. So that is comparing to your condition. These operators compare to your condition. Let's use a few of the comparison operators. Let's say I'm looking for the employees who are making salary, whose salary are more than 20,000, right? So we're looking for these employees. So we want to see, we want to know their first name, last name, and definitely salary, because that's what we're looking for. So if you're looking for salary, then let's say, okay, salary, select, we need to know the name. So first name, last name, salary from employees, and we put our condition where we said what? Where's salary, right? So there is a column called salary, right? Where is it? Select from employees. Salary, yes. So we are looking for where's salary, right? We said salary is greater than 20,000. So it's salary greater than 20,000, right? Let's run it. Oh, there's only one person whose salary is more than, and he is the president, I think. So this is the only person who's making salary more than 20,000. Now, if somebody is making exactly 20,000, will he be in this list?
What salary is that?
No, right?
No equal.
No equal, exactly. So if we want to see, okay, if it's more than or equal to, then we do this, right? So if someone is making exactly 20,000, he will be included. So there's nobody who's making exactly 20,000. Now this is a very good question. Do you know the CTFL certification exam? Anybody familiar? CTFL, there's a certification exam as a chapter. So in that, there is some questions regarding this, the inclusive and not inclusive. This is an interesting topic, I find. So inclusive is like equal to, greater than or equal to. So if it's inclusive, then it means that greater than or equal to. If it's not inclusive, then it means out of this range. Let's say there's 10,000 to 20,000. If it say okay 10,000 to 20,000 inclusive, that means 10,000 and 20,000 also will be the range. But if it says non-inclusive 10,000 and 20,000, that means if it will be after 10,000 and before 20,000. So it's in between. So it's 19,999 and 10,001. From 10,001 to 19,999. Okay, so let's stick with our thing. So this is one we saved. Let's see what else we can do. I have some questions over here that might be. Okay, now that you already know, tell me. I know there is a column called department ID. Tell me what is the statement for. I want to know the employee's name who works in department number 90.
Employee name, department number 90.
I want to know all the employees who work in department 90.
So select all.
Let's just select the first name and last name. I can copy it from here. Okay, I just need the names. So select first name, last name from table name.
Where department ID is 9.
Where department ID equal to 90. Fairly easy, right? Okay, so there's only 3 of them. I think there's one for 50. Let's see. One department had a lot of them. Yeah, 50 had a lot. Okay. Now I want to know the employees who does not have a manager. I don't know if there's a manager ID column. Let's find out. If not, then it will be a problem. Or supervisor, right?
There is a manager ID.
There is?
Yeah.
Okay, then, okay. So I want to find out who does not have a supervisor or who does not have a manager.
Select first name, last name.
Okay, select first name, last name. Let's just do it here. From employees, this part is same. Where part is same. So what is the condition?
Where manager ID is not.
Is no.
Is no?
Yes.
There should be only one.
Yeah. First one.
Yep, Stephen King is the one making 24,000, right? Okay, so this is the only guy who does not have a manager. Now let's mix it up a little bit. We're just having one thing. Let's add another thing. So now I want to know the employees who are making more than 10,000, whose salary is more than 10,000, and who is making a commission as well.
Oh, what?
I want to know the employee whose salary is more than 10,000 and who also have a commission.
Select first name and last name.
Okay. Okay, first name and last name. Let's keep the percent commission as well. From employees, this is the same, right?
Mm-hmm.
And then where? What is the condition?
What salary
Where salary is.
Where salary
is better than 10,000?
greater than 10,000. And good. You guys are getting it. And what was the other condition? Condition is they have beside the salary they have a commission as well. So and
Commission is not equal to zero.
commission underscore PCT
Is not equal to zero.
is not null or is not equal to 0. Okay, let's do not null. That's more common. We'll try with not 0. So these guys are okay. Let's try yours. Percentage. That should also work. Oh no, there's no 0. It might not work. But let's try. Yeah, it does. So see, we can do it in both ways. We can say is not null or we can say is not equal to 0. But this one sometimes it will not work in some condition. The condition is if it's not, because this one is a number, so it's working. But if it's a worker, then it will not work because it's looking for not null. It's looking for a null. It cannot be a 0 or it's not a number, right? Okay, so I think let's go to the joins. Yeah, that's the most enjoyable part, right? So first, before we do the actual joining, let's talk about joining for a moment. So what is joining, right? So we were talking before that, okay, the two tables are joined with the primary key and foreign key and stuff like that. So why do we need to join? First question is, why do we need to join? Why do we join tables?
To relate them.
To relate them, because they are related tables, right? They're related to foreign keys and primary keys. They're already related. But why we are joining them? What is our purpose to join? Because they're already related. When we created the primary key and the foreign key, we related them to each other. But what is
like what? To check the integrity.
So our purpose is, that's one way to put it, to check the integrity. But the primary thing is, because you have smaller tables now. Remember, we broke down the tables for normalization. We put the sales in one table, order in one table. We put the customers in another table. We put so if you want to know two things from two tables, we have to join the table to bring up the data from two tables. Let's say you want to know, let's say on this table, the employees table we were running, let's say there is two tables now. One is the salary information, one is the employee information, the personal information, another one is the salary information. So if you break down into two tables, and so now the salary is in one table and the employee's name, address, and phone number, those things are in one table. Now if you want to know the employee's salary, then you have to bring the two tables together. You have to join the two tables and bring them, the system will bring them up together to look like as one table to show you the information you are requiring, you are looking for. So that is the purpose of our joining. Now, there is basically two types of joining, as we all know. One is what? Inner join. Another one is outer join, right? So I like to use that circles to explain it. It's really good. So basically, let's see if I can use that. The Word document works. Is it coming up or not? Did I click it? Is it coming up? Man, how long does it take to come? So basically, there's a inner join and outer join, right? So inner join is when you join two tables and you want to see the common information between the two tables. That is your inner join. That is the most common joining, and when somebody says join, he means inner join. So inner join is it's so common that when somebody says join, that means automatically if somebody says okay join two tables, that means he is saying okay inner join two tables. What I was trying to show you is just a graphical representation basically, so that easier for us to understand. So let's say this is our table, first table, one table, and this is our second table, right? So let's say this is our two tables. So let's say this is our table, first table, table A, and this is our table B, second table, right? So if we join these two tables, this will look kind of like this. And so when we say the inner join, that means we are looking in this area. So this is the common area between these two, between whatever the common area is, that you will see only this information, because they are intercepting each other, and you need we are looking for the information that are in both tables. So that's your join, inner join or just join, same thing. Now when you are doing outer join, there's two type of outer join. I think you already know, just for a refresher. So the two outer joins are left outer join and right outer join. So okay, so left outer join basically is the table so left outer join is basically when you are doing a joining, and it will bring up the common information definitely, and all the information from the first table. So it will bring up all the information here from the first circle, basically from the first table. So it will bring up the common information as well as all the other information in the first table. Okay, so that's your left outer join, because it is bringing all the information from the left and the common. Obviously the right outer join will do the opposite, so it will bring up all the information from this circle, from the second table. So it will bring up the common information obviously and everything else in the second table. So that is your right outer join, right? Any question? No, okay. Let's go back to our command. What I want to do is I had some statements from previous ones. I'd like to use those. Wow, it's all saving. Let's save this here. Okay, so there are some saved stuff here. No, I don't see it. Anything else? Wanted to save some time, but don't see it. Let's see some questions. Oh, maybe I have it here. Yeah, and this way we can save some time. We don't have to create all the tables again. Forgot, just need the table names, FT customers and FT orders. Okay, that will do. Okay, so these are two tables actually I created before in the previous class, I think, to show the example of the joining. So I'm gonna use this class, these tables, so that we. What am I doing? Select all or select all. So we don't have to create the table again, and it will save some time. So these are two tables I have. One is called FT customers, and another one is called FT orders, I think. FT orders. Yeah. So these are two tables I have. And we're going to use these two tables for our joining example. So here, let's say we have our two tables. One is for our customer table. So these are the three customers I have in the table. So I have customer ID. These are the name and their address, whatever city they live in. This is our customer table. Let's say we're a sales organization. And then we have another table called order table, where whoever put the order, we enter the order amount here. So, okay, we want order number, this is the order ID, whatever product that is, and this is the amount, how much or how many units they ordered, and this is our customer ID, which customer ordered this. So this is over here, right? So, okay, now, who can tell me what is this column here?
Foreign key.
Foreign key, right? Exactly. So this is customer ID. This is the primary key in the other table here, cust ID. This is the primary key. Nida, it makes sense? Okay, so this is the primary key over here for this table, a unique identifier for each customers. And we add this column to the orders column. Order table. So this is the cust ID is foreign key over here and its primary key over there. If this order table is connected to another table, we will have another foreign key over here. If we add this order number to another table, this order number will be foreign key in for that table. So that's just a repetition. So now we want to do the inner join. By inner join, we want to know which customers order what and how much, right? So for inner join, we need to get information from two tables. So we want to know, okay, select, so let's go to the one. So I want to know the names and order amount of the customers. So I want to know the first name, and right. So I want to know the first name. Let me write this down first, and then I'll explain. Am I right? FT orders the cost ID. Something is missing. FT. Oh, here. See, I wrote the table name wrong. Now you're talking, huh? Okay, so let me explain this now. So now I said these two tables. We have our customers table, where we have all the customers information, and our order table where we have the order information, the order ID, and the amount of order, and who ordered what and how much. And this is our order table, right? So we want to know the information from both table and with the customer name and the amount they ordered, right? So to join two tables, as we are joining two tables, remember we did what? We did select. When we are retrieving information, we just select column name from table, right? So here we are retrieving information from two different tables. So we cannot just say select. Now if we say select column name, then the database will not know that which table to go to. So that's why we need to specify the table name with the column name as well. we said, okay, first one, so we need to know what, select the first name, but the first name comes from where? It comes from the FT customers table. So we said, okay, select FT customers dot first name, because it's coming from customers. We said FT customers dot last name, because it's also coming from the customer table. Whichever, you can do as many columns as you want. You just need to specify the table with the column name now, because you have two different tables. So you need to tell the database that, okay, this column is in this table, the other column is in the other table. So you're saying, okay, FT customers dot first name, FT customers dot last name. Then you say, okay, FT orders. This is a different table, FT order table. Amount, the column name is amount, and FT order is order number. So we want to see this information, 4 column from now 2 tables again, FT customers, comma, FT orders. So we have 2 tables. So now we told it what column we're looking for and from which table. Where, now it comes our condition, where the condition is what? FT customers, our first table, dot cust ID, where our customer table primary key equal to order table foreign key. Okay? So, and when we run this thing, when we run the statement, let's see what we find. We find this. We find first name, last name, amount, and order number. So this first 2 is coming from the customer table, and the second 2 columns are coming from the order table, right? So now we know, okay, if we look at the customer table, we don't know what they're ordering. If we look at the order table, that we don't know the names. We know the customer IDs, but we cannot see the names, so we cannot relate it to the customers easily. So now, if we join these 2 tables, we want to find out all the information together. We join them. Now it comes what? It comes at the same table as an inner join. Now, how do we know this is an inner join? I told you inner join, you guys believe me, but is it true or is it not true? How do we know? Because remember we said inner join is what? Inner join is we are looking for the common information, right? Not this one, where's the common, this part, right? The common between 2 tables. Is it actually the common information? Let's find out if it's the common. I think there's a mistake here. Okay, so look, what happened is, although we have 3 customers here, we have 3 customers, right? But in the order table, we have only, how many orders? Only 2 person ordered, 101 and 103. 102 did not make any order, right? So when we run the joining, inner join, any information regarding 102 should not be there. Let's see if that's the case. Sorry, I forgot which one was 102. Okay, so this person, Farhana Zaman, so this person should not be. These are the names of a couple of students from the other class. Okay, so we saw that 102 is not, 102 did not place any order, right? So 102 should not be, when we join the column, 2 tables, 102 should not be in there. Let's see if that's the case. Yes, that is the case, right? 102 Farhana Zaman, whatever Zaman for Zana or Farhana Zaman, her information is not here because we're doing an inner join, so it's only showing us the information that is present in both tables, right? Now, if we want to do the outer join, we want to do the left outer join. Remember how to do it? Very easy. Just add a what? Just add a plus sign, right?
Yeah, the plus sign.
Add a plus sign at the end. If you add it here, what will it be? Left or right? If you add the plus sign at the end,
And that will be left.
left. So if it's a left outer join, that means what? It's showing all the information from the first table. First table, right? So see, now we have this person as well. This person did not make any order, but as this is a left outer join, we want to see all the information from the first table. That's why it's showing this person as well, although their order column is blank. And this plus sign, if you move it to the left of the equal sign, that will be a right outer join. So the easy to remember way is, this is the equal sign, right? So if it's on the left of the equal sign, it will be a right outer join, and if it's on the right side, then it will be a left outer join. So it's the opposite, right? So let's run this and let's see if it shows us. Okay, so 1005. So now look, it's not showing the other person, because the other person is in the first table, and this is a right outer join. So we are looking for everything on the second table, not the first one. So this order, nobody made this order. It's just an ID was entered, but no order was made. So this is an amount. So this is a product which nobody ordered. But it's in the second table, so it's still showing as this is a right outer join. That's why it's still showing over here. And the other customer is not showing, because this is the other customer table is the first one. That's why it's not showing over here. Any question?
Yes, so can you run a query from employee table to the table we created with student?
Didn't get it, sorry.
You know, we created the table here, right? Can you run the query with the employee table that we have?
No.
Why?
First of all, you have to connect these two tables. You need to create a column for the other table. Let's say if you have a QA table, you need to have the QA table's primary key to employees foreign key, make it as a foreign key. Second thing, you need related tables like this. You just cannot run two tables for nothing, because let's say you have one table, you have a sales table, it has to be somehow connected. So let's say over here you have customer and sales. So this is one organization's two tables there. You need to know, okay, you can find out the orders, which customer made how many orders, things like that. So this has to be, so if there's same thing, like in our QA table, we had the first name, last name, same thing. In the employee table, you have the same column, first name, last name, same thing. So it will be very complicated to join these two tables.
Unless we have the primary key.
First of all, you have to have the primary key to add it, make it the foreign key on the other table. That's the primary condition. You have to do this in order to connect these two tables, right? And after that, there's the other things. It will be complicated because it has the same columns on the both tables. Got it? Okay. But you can still be able to, maybe you can able to connect it, but that's the first and foremost thing is the primary key and foreign key. You have to make them primary key and foreign key. Anyone else? Okay, basically, this ends our topic today. Anyone online have any question?
Sure, I have a question. Can we join like more than 2 tables?
Yes, you can.
Okay.
Yeah.
So do we have to make the primary key every time, like for every table, and then?
For every table, you definitely have a primary key. If you want to join more than 3 tables, it might not be. Let's say we have another table. Give me a second. So if we have another table, let's say we are connecting the order table to another one, right? So maybe the order table is not. Sorry, the order table is connected to this table, but the customer table is not directly connected, right? So if you want to connect the customer to the other table, then you have to go through this table. So you cannot, if this table's primary key is not a foreign key in the other table, let's call it the sales table, just for example. So if there's a sales table and the order is connected to the sales, but customer is not connected to the sales, then you have to you can still join them, but you have to go through. You have to connect this to this first, and then this to that, and this 3 will connect. You have to connect all 3 to get the connection from customer to sales. But let's stick with the primary thing now. We'll go there later. Sorry, I think I had a question from one of the person. Okay, my name is Ferdos. Let me write it down for you. It's this way. Okay, any other question?
One question.
Yes.
What do we do with the union and union all?
Union and union all. This is basically kind of joining. Not a very common. Union is basically like joining 2 tables, everything together. So union is basically over here. Remember we said common and outer. The union is basically showing everything from both tables. Yeah. Union all. I forgot that one. Union all. Union 2 tables and then union all. Yeah, sorry, I have to look for that one. Union all.
What is self?
Sorry?
Self-join.
Self-join? Self-join. Nope. Don't know that either. It's the first time I heard.
Yeah, it was just like first break table, then join back the table.
Self-join, I never did self-join.
I seen on somebody notes.
Yeah, okay. Okay, so let me write that down. Do you have a pen? I will have that answer for you. Yeah. Can I borrow your pen? Let me write it down so that we can have it. I actually, the person I was looking for my contact. I actually am not a regular teacher here. So if you need to contact me, you can email me at, let me write it on the here so everybody can see it. So if you want to email me, this is my email address. And any question, just send me an email. So union all is one. I need to know union basically both of them. All right, if there's no other question, I'm gonna end the WebEx, and if you have any question after the class, please feel free to email me, and I will. Hello? Yes.
Can you hear me?
Yes, I can. Yes, now I can hear you.
Thank you. My name is Said. Nice to meet you. I got a question. Probably you have the answer.
Okay.
I'm working on a database related issue. I'm trying to manipulate data from the Excel sheet from any IDE that I'm working with, let's say on web service testing. When I populate my connection string, my user ID and password, and the database name, I do get an error that connection was not successful. This is one thing, and another thing, I'm using MySQL database in order to manipulate with the data from the backend. So once I run my MySQL in my command prompt, not command prompt, in the MySQL command line interface, and I wanna interact with the application on a host, let's say localhost 8080. So once I go into localhost 8080, localhost 8080, I get an error. Do you have any solution on this thing? Do you know what I'm talking about?
I don't think I can give a solution in over here, but I can take a look at it and see how it's going.
If I share my screen with you,
let's not do it here, as this is being a recording.
Oh, you can stop recording because you're done with the class, no?
Yeah.
I thought you're done.
Yeah, give me a second. Give me a second.
Sure.